everybody, Ramey here, and today I'm going to talk about comparing two groups for statistical significance. In order to do that, we usually do this test called a t-test. Really simple to do, tons of calculators online in order to do it. So what does that mean, comparing two groups? Well, let's say I wanted to compare the results of pre and post something. So let's say I was comparing students before I learned my material and after, and I wanted to compare if they actually learned. So I was going to compare their test scores. Or let's say I wanted to compare my blood pressure from month 1 versus month 2. Or anything like that. I wanted to compare, the satisfaction of men versus women when they ate a piece of food. Any kind of comparison like that, I'm going to use a t-test for. Now, if I have more than two groups, if I have multiple variables, or I'm looking at something else besides this comparison, you're going to do a completely different statistic, not a t-test. I'm showing you how to do a very basic comparison between two groups. Okay, it's really easy to do. Let me show you how to do it. So let's look at the screen here. And what I've done is I have I've just typed in Google t-test calculator. There's tons of them out there. So just search Google t-test calculator. You're going to find 20 of them. They all do the same thing. All right, so let's imagine that I am comparing a class. Actually, two classes. I want to compare the satisfaction between two classes. They could rate my scores between 1 and 5. The first group, I just gave my class to normal class. At the end, I said, give me a satisfaction report. The second group, I threw a pizza party at the end of the class. Then I gave them the test and told them the satisfaction and said, how do you rate my class? So group 1, no pizza party. First thing I like to do is just eyeball my data and see, what does my data look like? Without me running any stats whatsoever, what do I think I've got here? Okay, so 1s and lots of 2s. So that means it didn't sound like my students were that satisfied. They didn't like my class. Urgh. How can I improve it? Okay, so class 2, I threw a pizza party. Let's look at the satisfaction scores. Well, just eyeballing this data, I see lots of 5s and 4s, which was highest. Way to go. I'm an awesome teacher. Or it was really good pizza. All right. So what I'm going to do, I'm not even going to touch anything here. So I'm just going to keep my significance level at 0.5. That's the most common. And I'm going to calculate my results. Okay. So when I calculate my results, they're going to show you tons of data. But you're not here for all this enormous. You just want to see, is there a difference and what was the difference, right? That's what most of us want to see. Okay, so they're going to give us a lot of different kinds of data here, which is really good in some regards, but I'm going to show you just some of the key things that you want to look out for. All right, so the first things I want to look for is I'm going to go over here and look at my data. You can see it here on the left. All right, first thing I want to look at are my means of each group. I see M1. This is my mean. So the mean of group 1 was 1.47. The mean of group 2 was 4.58. So again, eyeballing those two means, that's a big difference between the lowest and highest. So it seems like there was a significant difference. Let's scroll down even further. Okay, the p-value was 0.00001. The result is significant. P is less than 0.05. So what we're seeing is that I had a significant difference. Now, when I say something significant, I'm not proving anything. Statistics doesn't prove. So I'm never setting out to prove something. What I'm doing is I'm saying here, hey, I'm looking at this data, I'm eyeballing it. It looks like there's a significant difference here. When I run it through a t-test, it's also telling me there's a significant difference. So it seems like I'm making a good case. Basically what you're doing with stats is you're building a case to try to conclude something. I'm not proving, I'm trying to draw a conclusion. So it looks like I have a really strong case that there's a difference when you eyeball the data. There's a reason why I think there's a difference, which was the pizza party. And my statistics are now showing a significant difference. All those three pieces together help me conclude that there was a significant difference between these two classes. Now, one of the things I want to show you is, let's say I mess up one of these data fields. All right, so I've just entered 5 million into one of the data fields by accident. Let's see what happens with my test. First of all, when I go to look at the means, I see the first mean is whoa, that's 25 million, 2.5 million, something's going on there. My second means 4.5. Okay, so immediately, like, I'm seeing some kind of error. I'm also not getting a significant result, which also seems weird because those are so different. So immediately, whenever I see statistics and I see like something that's not expected, and I see like, hey, some numbers seem off, this seems really weird, what's going on here, why is it like this, I'm going to say there might be something off in my data. I'm going to go back and check and say, you know what, there was an outlier here. This, either I messed up entering this score in, or this person like completely messed up entering their data in. That one score needs to be eliminated because it doesn't make sense for this data set. Something was really off there. Probably I just entered it in incorrectly. Then I go back and run my test and see what the score really was. So you always have to look at your data, compare the groups, and then you make some conclusions.